Okay, so our goal for today is to be subtracting rational numbers. So our essential question is, how can we use what we know about subtracting integers to subtract rational numbers? And we are going to be using that understanding to actually subtract rational numbers today and to solve some real life problems. Okay, so when we're subtracting rational numbers, in words we have this for us, we can see that they want us to subtract rational numbers using the same rules for signs as we did for integers. And the rules that they gave us for this is when we are subtracting integers, we are going to be turning it into an addition problem, and we're just going to be adding its opposite. So if we see we have a 3 minus a positive 4, what we can then change that into is 3 plus a negative 4. So now that we have this, we can then follow those integer rules for adding, and then we can figure out that our answer is -1. So when we are subtracting a positive number, we are going to be thinking of it as the same as adding a negative number. And when we are subtracting a negative number, we are going to be thinking of it the same as adding that positive number. So in kind of layman's terms, when we are subtracting integers, we do not want to just go ahead and subtract those integers, okay? We want to change the signs, and we want to think of adding the opposite, okay? So we can keep the sign of the first number. So over here, we kept that sign as a positive 3. Then we're going to change the subtraction sign to addition. So this subtraction sign became a plus sign. And then we're going to change the sign of the second number to the opposite sign. If it was positive, it's going to become negative, and if it was negative, it's going to become positive. So this was positive, and we changed it to negative. Okay, and then once we can have that down, we can then use those same rules that we had yesterday in adding those integers. If they are the same sign, we're going to go ahead and add them like normal, and we are going to then just keep the sign. And if they have different signs, we are then going to just subtract the bigger from the smaller and then keep the sign of that bigger number. Okay? So for example 1, we are going to be subtracting some rational numbers, and because we are subtracting rational numbers, that includes working with fractions. So as we look at this, the first thing that we want to do is turn this mixed number back into an improper fraction. So 7 times by 4 is going to be 28, and 28 plus 1 is going to be 29. So I have negative 29 over 7 minus a negative 6 over 7. So since we see a minus sign here, we want to think about, oh, I want to change that to an addition problem. So since we have minus a negative, we can think of that as the same as adding a positive. So we can just think of this as addition. Okay, so we can go ahead and just think of this as one big addition sign. So now I have negative 29 plus a positive 6. And now because I'm adding integers, I'm using those integer rules, and I'm going to say, since I'm adding the opposite signs, negative and positive, we can then just treat it like normal subtraction. So I'm going to do 29 minus 6, and 29 minus 6 is going to be 23. And then because my bigger number was negative, it's going to be negative 23. So I have negative 23 over 7 as my answer. Then for the second problem here, again, I need to turn these mixed numbers into improper fractions. So this is 8 times by 3 is 24, plus 2 is going to be 26. So this is going to be negative 26 over 3. And over here I have 6 times by 6 is 36, plus 1 is going to be 37. So I have now 37 over 6. And I see that this negative 26 over 3 is going to be subtracting that 37 over 6. So again, my next step here is to make sure that my denominators have the same sign. So in order to make sure my denominators have the same sign, I need to change this 3 into a 6. So to do that, I'm going to times this by 2. And I can also times the top by 2 to make sure that this number doesn't change, that it stays the same value. So at negative 26 times by 2, I'm going to end up with negative 52 over 6 minus 37 all over 6. Okay, so now as I look at this, I see that I have a minus sign here in the middle, and I'm subtracting a positive number. So I'm actually going to change that because I want to add the opposite. So I'm going to be adding a negative 37 over 6 now. So now when I look at this, I have negative 52 plus negative 37, and I can just do that off to the side, and I can say that 52 plus 37, because a negative plus a negative we're going to treat like regular addition. So 52 plus 37, 7 and 2 make 9, 5 and 3 make 8. So this is going to become an 89, and this is a negative plus a negative, so it's going to be a negative 89 all over 6, because we're going to keep our denominator the same. Okay, so this is going to be our answer right here. For example number 2, we're going to be subtracting rational numbers. So we're going to find the difference between 12.8 and 21.6. So 12.8 minus 21.6. So what we're going to be doing here is we're going to be changing this subtraction sign into an addition sign. By doing that, we have to make this a negative number. So now we have 12.8 plus negative 21.6, and now we can follow those regular rules of adding integers. Since we are now adding a positive and a negative, we're going to treat it like regular subtraction. We're going to take the bigger number minus the smaller number. So 21.6 minus 12.8. So 6 can't take away 8, so we're going to borrow here. This is going to become 0. This is going to be 16, so that's 0.8. 0 can't take away 2, so again we have to borrow. This makes 1, and we have 10 minus 2 is going to be 8, and 1 minus 1 is 0. So I end up with 8.8. Now I need to determine if this is positive or negative. So my bigger number was negative, which means that my answer is going to be negative. So my answer is going to be negative 8.8. As I look at this next problem right here, I see that I am minusing a negative number. Well, we're going to turn this into a plus sign. So when I'm plussing, I have to add the opposite. So that means I have to add a positive 0.96. So now I have negative 3.75 plus 0.96. Since I'm adding a negative and a positive number, that means I'm just going to treat it like regular subtraction. I'm going to take the bigger number minus the smaller number. So 3.75 minus 0.96. 5 can't take away 6. We're going to borrow. This is going to become 6. 15 minus 6 is going to be 9. 6 can't take away 9, so we're going to borrow here, and this is going to be 2. And 16 minus 9 is going to be 7. So I end up with 0.79, and 2 minus 0 is 2. So I end up with 2.79. Now I just needed to determine my sign, whether it's positive or negative. I come up here and I see that the bigger number was negative, so my answer has to be negative 2.79. Okay, so go ahead and try these on your own. Once you're done, you can go ahead and resume the video and check to see if your understandings match with mine and that your answers line up with mine as well. So as we are finding the difference here, we have 1/3 minus negative 1/3. So what we can do is we can turn this into a big plus sign, because minusing a negative is the same as adding a positive. So 1/3 plus 1/3 is going to be equal to 2/3. Then for problem number 2, again, we need to change this into an improper fraction first. So 3 times by 3 is 9, plus 1 is 10. So I end up with 10 over 3, and it is negative 10 over 3 plus 5 over 6. So my next step is to make sure that I have the same denominators. So in order to get the same denominators, I'm taking 3 times by 2 and 10 times by 2. So I end up with negative 20 over 6 plus 5 over 6. Now because I have a negative number plus a positive number, I'm just going to do regular subtraction. So 20 minus 5 is going to be 15. I know this 15 is going to be negative because my bigger number was negative. So it'll be negative 15 over 6. Then for this next problem, again, we need to first make these into improper fractions. So 4 times by 2 is going to be 8, plus 1 is going to be 9. So now I have 9 over 2 minus 5 and 1/4. And I can make that 5 and 1/4 an improper fraction by taking 4 times by 5, which is 20, plus 1 is going to be 21. So it's going to be 21 over 4. And again, I need to make sure that I have the same denominator for both of these fractions. So I need to times the bottom of here by 2 and the top of here by 2. So I end up with 18 over 2 minus 21 over 4. And now I can go ahead and look at this and say, well, I don't want to subtract a positive, I want to add a negative. Since I'm now adding a positive and a negative, I can treat it like normal subtraction, and 21 minus 18 is going to give me 3. Now that 3 is going to be negative because the bigger of those two numbers was negative, so I'll get negative 3 over 4. Sorry, this should have been a 4 right there. Then, as we move on to problem number 4, we can see that we have negative 8.4 minus 6.7. So I don't want to minus a positive, I want to add a negative. So now I have a negative number and a negative number, so I can treat those like regular addition now. So I can do 8.4 plus 6.7, line up those decimal places. 7 and 4 make 11, carry the 1. 8 and 1 is 9, plus 6 is going to be 15. So I end up with 15.1 as my answer. Now I just need to make sure I have the correct sign. Since both of these numbers were negative when they started, that means we are going to end up with a negative number. So it'll be negative 15.1. Then as we look on to our next problem right here, we have negative 20.5 minus negative 20.5. So I can actually turn this into a big addition sign because minusing a negative is the same as adding a positive. So I now have negative 20.5 plus 20.5. So now we are adding opposites, and when we add opposites, our answer is going to be 0 because they are going to cancel each other out. Then on this last one right here, we have 0.41 minus a negative 0.07. So again, when we're minusing a negative, we can turn this into a giant plus sign and know that we are adding 0.41 and 0.07. So we can just do this is positive and this is positive, and we can just treat it like normal addition. So 0.07 plus 0.41, and we're going to end up with 8 and 4 and decimal. So we're going to end up with a 0.48 for our answer. So for example 3, we're going to be finding distances between numbers on a number line. As we're finding the distance between two numbers on the number line, we can do that by finding the difference of the numbers. So we can figure out how far it is from negative 2.23 all the way up to 2 and 1/3 by taking 2 and 1/3 and subtracting negative 2 and 2/3. So as we do that, again, we're going to look at this and we're going to see that this is minusing a negative number. So as we're minusing a negative number, we can actually turn that into adding a positive number. So now we have 2 and 1/3 plus 2 and 2/3. So we can go ahead and just add those together and we can get 4 and 3/3. And when we have 4 and 3/3, that's actually going to be equal to 5. Now, if we didn't see how we did that, we took our mixed numbers and we added them together, and we saw that our denominators were the same, so we just added our numerators together. But if we want to turn these into improper fractions first, 3 times by 2 is going to be 6, plus 1 is going to be 7. So we'll end up with 7 over 3 plus, and 2 times by 3 is 6. And 6 plus 2 is going to be 8, so I have 8 over 3. So 7 plus 8 is going to be 15 over 3, and 15 divided by 3 is going to be equal to 5. So the distance between these two numbers on a number line is going to be exactly 5 units. So for an extra example on this, we're going to be finding the distances between numbers on a number line. And in order to find the distance between two numbers on the number line, we are going to subtract them to find the distance between them. So if we're trying to find the distance between 2 and 3/4 and 3 and 1/4, what we're going to do is take 2 and 3/4, and we are going to subtract negative 3 and 1/4. And when we are subtracting these numbers, we can see we're subtracting a negative, which is going to be the same as adding a positive. So if we turn these into regular improper fractions, 4 times 2 is 8, plus 3 is 11, so I now have 11 over 4, plus 4 times by 3 is 12, plus 1 is 13, so 13 over 4. 11 plus 13 is going to be 24 over 4. So 24 divided by 4 is going to be equal to 6. So the distance between these two units on a number line is 6. So looking at our first real-life example of subtracting rational numbers, in the water, the bottom of a boat is 2.1 feet below the surface, and the top of the boat is 8.7 feet above the water. Towed on a trailer, the bottom of the boat is 1.3 feet above the ground. Can the boat and trailer pass under this bridge? And our bridge is 11 feet and 8 inches tall. So what we are going to need to do is break this into two pieces. The first piece, we need to figure out the height of the boat, and then we need to figure out the height of the boat on the trailer. So as we figure that out, we will then be able to determine if that number is bigger or smaller than that 11.8 or 11 feet 8 inches in order to say, yes, it can fit under that, or no, it can't fit under that. So the first thing that we are going to do is to find the height of the boat. And in order to find the height of the boat, what we can do is set up an equation. So we can say h is going to be equal to 8.7 minus that negative 2.1. And the reason that we are doing it is because in the water, the boat is going to go 2.1 feet below the surface of the water, and it's going to go 8.7 feet above the surface of the water. So if the bottom of the boat is 2.1 feet deep and the top of the boat is at 8.7 feet above the water, the difference of those two is going to be the height of our boat. So what we can do is we can add the opposite of 2.1, so minusing a negative is just going to become adding a positive. So 8.7 is going to give us 10.8. So we know the height of our boat is 10.8. So the next thing that we need to do is find the height of the boat and the trailer together. We know that the boat is 1.3 feet off the ground when it's in the trailer, so we can take that 10.8 as the height of the boat, add that 1.3 to it in order to figure out how high the boat is going to come up off the ground. What we're going to find is that's going to be 12.1, and since 12.1 is greater than 11 feet 8 inches, we can say that the boat and trailer cannot pass under this bridge, and so they are going to have to find an alternate route. So our next real-life application here is we have $101.62 in our savings account. If we withdraw $45.41 to pay our cell phone bill, will we have enough money left to buy a video game that costs $49.99? So what we need to do is we need to take this $101.62 and we are going to subtract that $45.41 in order to figure out how much left we have in our account. So 2 minus 1 is 1, 6 minus 4 is 2. 1 can't take away 5, and we can't borrow from 0, so we have to borrow from 1. That makes this 10. We have to borrow from that 10, which makes this 9, which makes this 11. So 11 minus 5 is going to be 6, and 9 minus 4 is going to be 5. So we end up with $56.21, and $56.21 is greater than that $49.99, and so we should have enough money left in our account to buy that video game. So go ahead and try these on your own. Once you've finished them on your own, go ahead and resume the video to check to make sure your understandings line up with mine and that we got the same answer. So we're going to find the distance between negative 7.5 and negative 15.3 on a number line. So in order to do that, what we have to do is we have to take the difference of these two numbers. So we can take this negative 7.5 and minus a negative 15.3. So since we are minusing a negative number, what we're going to do is we are actually going to change this into adding a positive number. So we now have a negative plus a positive, which we can treat like regular subtraction. So we're going to take our bigger number, which is this 15.3, and subtract this 7.5. So now we have 15.3 minus 7.5. And we're going to have to borrow in order to take away, so we're going to have this become a 4, and 13 minus 5 is going to become 8, and 14 minus 7 is going to be 7, so we end up with 7.8. So they are 7.8 away from each other on a number line. Now I do need to make sure that my sign is correct, so our bigger number here was a positive, so yes, it is going to be a positive 7.8. Beautiful. Now, as we move on to this next question right here, we can suppose that the clearance of that bridge is 12 feet and 1 inch. Would the boat and trailer be able to pass under the bridge? So if the height of our boat is at 10.8 feet and the distance from the bottom of the boat to the ground on the trailer is 1.3 feet, we can then add these two numbers together in order to figure out if that is going to be low enough in order to go underneath that trailer. So as we do that, we can do 10.8 plus 1.3. So as we do that, 8 and 3 is going to be 11. Carry that 1, and we're going to end up with 11.1 as our height and of the trailer and the boat. So as we do that, we can see 11.1 feet is lower than 12 feet and 1 inch. So we can say yes, that our boat will be able to pass under this new bridge. Okay, and now we have our mini assessment here. Go ahead and try these problems on your own, and once you've done that, go ahead and get this ready for me on Friday when I will be able to check your work.